Hello, welcome back for another lecture. In this lecture we're going to go ahead and design a reinforced concrete beam, and the beam is got rectangular cross sections and a 22 feet simple span. Our concrete is 4,000 psi, our steel is going to be 60,000 psi, and live load 2 kg per foot, and a dead load of 1 kg per foot, not including the weight of the beam. As we go along, we figure that out. So one of the first things you do when you design a concrete beam, you're going to come up with the dimension for the cross section. A lot of time the architect maybe already have gave you the depth of your beam because it's based on a floor height and a ceiling and stuff like that. And if they don't give it to you, then you can go ahead and use the table on ACI, table 9.31. If you look at ACI 9.3.1, it kind of give you an idea of what to use, and they say it's the minimum is L over 16. So if you have the minimum of L over 16, ours is going to be 22 feet. Make that to an inch divided by 16. That will give me about the 16.5 inches. So what does it mean? It means it cannot be less than that. So what about if we go just L over 10 for our guess? If we do L over 10, we can guess at that, and that comes out to 22 times 12 divided by 60 by 10. I'm doing good. That's come out to 26.4 inches. And one of the things is, when you come up with a number, make sure you go to the whole number. Don't use 26.4. Say we're going to use 27. So we're going to make that 27 inches. And that's our equal H. And our B, it's going to be basically half of that. Let's go with half of that. H divided by 2, that's about 14 inches. So we're going to go ahead and use this to our dimension. And when you do a rebar, you already know that say if you have a rebar right here in the middle someplace, you need a depth of cover. You know, wonder what the D is, our effective depth. So your D usually, if we go into, it's right on the board over here, ASI 20.6.113, it tells us that D can be equal, let me use a different color here so we can see it better. D can be equal H minus cover, and then minus the tie depth or stripper, whatever you're going to put on there, and minus the diameter of the bar divided by 2. And if we go ahead and follow that, our D comes out to 25 inches. Let's see how we're going to come up with 24. So I have equal 27, and the cover per spec is 1.5. Take that off, and let's give this one usually is about 3/8 or 0.375, and the diameter bar, let's just say use, if we number 9, number 7, let's use number 9 for now. So it's a 0.5, that's which is 1 inch divided by 2, make it 0.5, and that comes out to 24.6. So let's say our D is equal 24.5 inch. Okay. Now we have calculated that. The next thing we're going to go ahead and calculate is our load. Let's find the dead load of the concrete, weight of the concrete, and we have 27 by 14. 27 times 14, that's inches. Let's make that to a foot, divide by 144, so make it a foot square, and then multiply by 150 pound per cubic feet. And if you calculate that, that will come out to 394 pounds per foot. or we can say 0.394 kip per foot. So now my W, it's going to be dead load plus live load, and let's figure out what our W comes out to. If you look at the ASCE 7, it tells you you have two load combination. One is 1.4 times D, and the other one is a 1.2 times D plus 1.6 times L, live load. And which one control? I don't have to even figure this out. I think this one will control. We know it anyway. So let's figure out what it'll come out to. 1.2 times, we have 1 kip dead load plus the weight of the beam, which was 0.394, and then plus 1.6 times 2 kip. So our load gonna come out to 4.837. 73 kip per foot. Okay. So now I have calculated that. I want to know what is my maximum moment due to this load. And if you look at any back of any steel book, concrete book for beam formula, the maximum moment for this type of beam is WL squared divided by 8. So my MMax is coming out to maximum moment. We call it MU. In this case, comes out to W, which is 4.873 times L squared. L was 22 feet square, and divide that by 8, and it comes out to 294.8 kip foot. Let's convert this to an inch foot and multiply it already. 294.8 times 12, and that gives me let me change it. $37.6 kip inch. Next thing we want to calculate is its rho, which is basically area of the steel and percentage of the steel inside of the beam itself, which will be BD here. And how are we going to come up with this number? There's a couple of, all right, so there's a formula here to calculate rho, and of course if you're an experienced designer, you're not going to have any issue. You know what is going to be, you're going to pick for your rebar, what size of rebar you need. But if you're not, this is one way it can kind of give you an idea how to do this. Of course, there is this formula, and if you're studying for your PE exam or structural engineering exam and you have the manual for that, they do a little bit different. I will do it both way, and we come up with the same result. So if I plug in all this number, my first I'm going to find out what Rn is. So Rn is equal, let me use a different color here so kind of distinguish a little bit. This is good, pink is good. Rn is, I got MU divided by BD squared, phi times BD squared. And it's talking about phi here. Our phi is basically, let's say we're going to assume phi is equal 0.9. That's not a good looking 0.9. 0.9, and if we look at the ACI 21.2, that's where this gas come from, and I've just put it on the screen right there. So now we're going to calculate the MU this, and that comes out to, we have already calculated, come out to 35 from previous one. We had 37.6 divided by 0.9 time 14, and D was 24 and a half. I erased it, but it is 24.5 square, and that comes out to 467.7 psi, and then we're going to plug that in there. Our rho is going to come out to 0.85 times 4,000 and divided by 60,000 multiplied by 1 minus square root of 1 minus 2 times 467.7 divided by 0.85 times 4,000, and that should give me 0.00842. All right. Now again, if you have the PE handbook, this is calculated a little bit different. KU is equal MU divided by BD squared, and that comes out to, we had the number from MU, which I erased, it was 294.8. and multiply that by 12, that's a cable, multiplied by 1,000 to make it a pound, and then I have BD squared 14 times 24.5 square, so I end up with 420.967. 420.967. Now I take that number and divide that by KU divided by F prime C, so it's come out to 420.967. My marker is drying out on me, and 4,000. That comes out to 0.105. Now you take this, there's a table in the back of your PE handbook. Now we have found that, so you take this to a table in the back of the book, and you see a symbol look like a small W, and you're going to look for that. From there, that comes out to, from that chart comes out to 0.126, and you take that. Now we have the formula for rho, which is equal WF prime C divided by Fy, and I have 0.126 times 4,000 and divide that by 60,000. Comes out to the same number, 0.00842. Okay, I need to erase this. 1, 2, 3. So now we have that. We're going to find out the area of our steel. So AS comes out to rho BD, which is equal 0.0084 multiplied by BD 14 by 24.5, and that gives me about the 2.89 inch square. So now we have that. Let's say we're going to use so let's say 3 inch square. And if we go into a table in back of any book, we can use number 9 rebar, and that's basically 1 1 inch. So that will give us 3 number 1 rebar, 3 number 9. Or we can have 5 number 7, which will give me 3.1 inch square, and this will give me a 3 inch square. 3 number 9. Come back in here. I'm going to use 3 rebar. Let's use just 3 of them. You could use 5 either way, but if you use 5 number 7 rebar, you have to, based on a table which is on a screen, you got to make sure you have enough width. With the number 9 rebar, we have a sufficient enough width, which is 9.8 is minimum, and we kind of clear that anyway. So now we have that. Let's go find out what is our actual row is if we're going to use this 3 number 9. So I'm going to have our row. It's going to come out to AS divided by BD, and which is 3 divided by 14 times 24.5, and that comes out to 0.00857. Now, if we look at the code usually gives you the minimum for area of the steel, or we can say this is bigger than the minimum. Row minimum is basically 0.003, and your maximum is 0.018, and also is less than 0.018. So that checks out. We go over here. We're going to find the size of our stress block. So A is going to be, the formula for it is ASFOY, and divide that by 0.85 F prime C multiplied by B. So now we have 3 times 60,000 divided by 0.85 times 4,000 and time 14 inch. So that gives me I got 3.78 inches. Great. Now we have that. From there, we're going to go ahead and use the other formula, which is phi times MN. That's equal to phi times AS multiplied by FOY and times D minus A divided by 2. So that comes out to 0.9 times 3 times 60,000 multiplied by D was 24.5, and whoa, minus 3.78 divided by 2. Okay, so that comes out to okay, 3662, that's an inch kip. 3662 inch kip, which is basically, if you divide it by 12, and that comes out to 305.2 kip foot. Okay, I just erased the board so I could have some more room. So our moment came out to 305.2 foot kip. So that is the capacity of this beam that we just designed. That's how much moment capacity has. We're going to compare to that to the beam, to the applied load. If you remember, we calculated this applied load came out to be, the maximum moment came out to 294.8 kip. This should be less than that, which it is, and that's going to check out. So we're going to say, all right, that's more than the applied load, and it's not going to fail. It's going to hold So that's good. So now what we're going to do, let's take a look at this. Bring this a little bit, make it a little bigger. If we kind of blow that up a little bit right here, we have our bar. Say we've got a bar here, 3 of them. From the center of the bar, our effective D was, we measured to become 24.5, and this was 2.5, so that makes it 27. And here we have 14 inches. And if we space this out at 4 inch apart, say this is right in the middle, we got 4 inch apart right here. So that's 8 inches. 8 minus 14 becomes 6. That will leave us 3 outside. So that will be 8 and 3 inch outside, which is kind of good. It will give you enough cover. This is it, and have a wonderful day.